Okay, hello everybody. Today, in this particular set of notes, we're going to look at ChemQuest 30. Right? That is the moles and reactions. We're going to take a close look at critical thinking 1 through 4. Now, my assumption is that you've done the LT 6.3 notes already, right? So if you were present in class, right, you should have done that with me in class. Right? If you were absent and you've not taken the LT 6.3 notes yet, hit pause on this video, go back to the playlist, find the LT 6.3 notes, and do that video first. Because my assumption going into this is you've already done those notes, you've already written down the 4 steps, so we're going to move a little bit more quickly through the processes this time. All right? So make sure you do that. Otherwise, you might be a little lost as we go through. Okay. So let's take a close look at number 1. So critical thinking number 1, it says to take a close look at the propane combustion reaction, just the same reaction by the way that we used in the topic 6.3 notes. So we're going to have some familiarity here. All right. So in question number 1, it says how many moles of water? All right. So this is going to be my question mark here for water are produced when 1.45 moles of propane. 0.45 moles of propane are combusting. Again, we're assuming there's plenty of oxygen present to actually burn up all 1.45 moles. Now, we need this balanced reaction because it tells us that for every 1 mole of propane, we get 4 moles of water. So if we have 1.45 moles of propane, we should be able to just multiply that by a 4-to-1 ratio to get the moles of water. And that looks something like this. So I'm going to go 1.45 moles of propane. Okay. I'm going to multiply it by the mole ratio. All right. So a ratio in this sense is going to be set up like a fraction. Whatever we're starting with goes on the bottom when we multiply, okay? And then whatever we're trying to find, in this case that would be moles of water, goes on top, okay? Now all I'm going to do is take my coefficients and plug them in. So water has a 4 next to it, propane has essentially a 1 next to it, an imaginary 1 there, okay? So when I multiply here, I'm going to go 1.45 moles times 4 moles of water per mole of propane. I can even do a little unit cancellation there, so my answer will be moles of water. All right, now, so it's going to be 1.45 times 4. We don't have to divide by 1 because we're just going to get the same number, but if this were not a 1, we wouldn't need to divide by whatever's on the bottom. So we always multiply first, 1.45 times 4, divided by 1. I'm going to do that. I should get 5.80 moles of water. All right, so now we know if we have 1.45 moles of propane and we completely combust that, we're going to produce 5.80 moles of water because of that 1 to 4 ratio. So 1.45 times 4 is 5.80. Okay, now we also have already learned the math. We want to know how many molecules of water that is, for example, right? We'll just use, going back to topic 6.1, okay, and use that process. I'm going to go from moles to representative particles. Remember, representative particles is atoms, molecules, etc. All right, which means I'm going to multiply by Avogadro's number. Okay, so the way I've set that up to show the calculation, I'm going to take my 5.80 moles of water vapor times 6.02 times 10 to the 23rd. In this case, it's molecules of water per 1 mole of water. Cross off the moles, and when I do that calculation, I should get 3.49 times 10 to the 24th molecules of water. All right, moving on to number 2. If 2.35 moles of carbon dioxide are produced, how many moles of water would be produced, right? So in this case, I know how much CO2, so I can just use my 3:4 ratio to calculate this one. So I'm going to go 2.35 moles CO2. I'm going to multiply by my mole ratio, so set up the fraction. CO2 is what we're starting with, which means moles of CO2 goes on the bottom. The coefficient for CO2 is 3. All right. We're trying to calculate water, so moles of water goes on top. The coefficient is 4. All right. So in this case, I'm going to go 2.35 times 4, then divide that number by 3. And when I do that, I should get 3.13 moles of water. All right. Number 3, it says, why is the following statement false? If 10 grams of propane burns, you need 50 grams of oxygen. Okay? Now, basically, that is a 1:5 ratio by mass. Okay? We have a 1:5 ratio, but that is per on a molecule or mole basis, right? This is untrue. So this would be a true statement if that said moles and that said moles, right? That would be a true statement, but they don't have an exactly equal molar mass. Therefore, that is why that's false. All right. So the 1:5 ratio applies to molecules or moles, not mass. And grams is a mass measurement. Okay, and on to number 4, last one for this video. Still sticking with the propane reaction. Let's go red this time. So if 27.3 moles of carbon dioxide are produced, okay, during the combustion of a certain amount of propane, how many moles of propane were combusted? All right, so again, we're just going to use our 3:1 mole ratio. This time we're starting with the amount of CO2, so it's going to be 27.3 moles of CO2. All right, I'm going to multiply by my mole ratio, so set up my ratio as a fraction. I'm starting with moles of CO2, so moles CO2 goes on the bottom this time. The coefficient for CO2 is 3. All right, and I'm trying to figure out propane, so moles of propane goes on top. And that coefficient there is a 1, right? So I'm going to go 27.3 times 1 divided by 3, and I should get 9.10 moles of propane. All right. Now, sig figs, well, that's why I'm adding that 0 there. We have 3 sig figs in our measured quantity, so we need to have 3 sig figs in our answer. Okay. Now, how many grams of propane is that, right? So I'm just going to go from moles to grams, which means I'm going to multiply by molar mass. Okay, so molar mass of propane, I think we figured that out in topic 6.3 notes, but 3 carbons plus 8 hydrogens has a molar mass of 44.11. All right, so I'm going to take 9.10 moles of propane. All right, I'm going to multiply by the molar mass, which is 44.11 grams of propane per 1 mole of propane. Moles are going to cancel. I'll be left in grams. And when I go 9.10 times 44.11 divided by 1, I get 401. Oops. grams of propane. Skadoosh.